to make this.
Asif, could you record this?
Yes, that's exactly what I'm doing. I'm
Thank you.
starting the live broadcast and it will start recording right after that. Give me a moment. There we go. And where's the record? All right, guys. So let's start today's session. I hope all of you are here and some may be joining in a bit. Well, first of all, guys, I have been sending you emails and I'll try to send emails. Though, first I'll announce things in this announcement section of the course portal. I mentioned last time that it is important to keep track with the portal and the updates to the portal. I don't know if you folks are getting those updates on your cell phone and on your iPads and so forth. I hope you're getting that. The alternative is, of course, to log in here and see the updates. I might occasionally forget to send emails, but the updates here will be there. As you can see, there are three announcements. First is the survey and week zero quiz are overdue. When the YouTube videos became available, I posted them. So if you look at this, you have the announcements for the videos. For the
You're
YouTube.
getting quiet again.
Oh, it's getting quiet again. All right. So the videos are there in the uh, course website. Then we also have other announcements. If you look around, you'll see that there, the first session today evening, that of course is history now. So there will be announcements on the portal every day. Other than that, there's a social forum. I haven't seen any activity there, guys. You'll get a lot more out of this workshop if you obviously engage with it a bit more. I noticed there are 4 replies to it. The homework start from today, so it would really help you to engage. Now, here's a suggestion. I This is collective learning. So as you solve the problem and you do it, share your findings with each other. See what things you tried and not tried, discuss it on the social forum. And an engaging social forum is very helpful, trust me, in learning the material. People come up with very interesting findings as they go along the workshop. And then part of the social learning you'll notice is that in every section, I try to put a wiki here. So for example, for quizzes and interview questions, you're most welcome to contribute your own questions. You come across an idea, a topic. We didn't ask that question. You can add those questions in the wiki here. Likewise, for the hands-on lab, you can contribute your own suggestions on how to make the lab better. You want to add a few puzzles on the data sets that we are doing. Feel free to do that. You can even put tips on how to run this. You know, some of you will get stuck. Maybe I don't use Mac. If you're using Mac, I use Ubuntu. So I may not be able to help you, but some of you, if you find solutions for each other, you can help each other by contributing it to the wiki. So do that. Now, today, I have uploaded the week 1 lab and homework. Please start by downloading it onto your machine and unzipping it. I believe on Windows, Nisarg is mentioning that you have to unzip it twice. One unzip leads to a tar file and a second unzip then finally unzips it. On Linux, of course, it is a simple tar xvfz command that will in one shot unzip it. So try that, guys. Huh? First, have this ready. Now, the way I'm going to do this workshop is first, I'll keep it simple. I'll keep 2 pieces separately. We will first make all of this work on your local machine so that you have a local development environment and a sense of how to do development on your local machines. Once we have done that, after that, uh, we will then move on to the cloud. We'll do it in Colab and we'll do it in Jupyter Notebooks in the cloud. First, we'll do in Jupyter Notebooks on your machine first. So these are two separate things. And if time permits, we will not only set up Colab and Jupyter Notebooks in the cloud, we will also bring up this project into the Jupyter Notebook and the Colab. I will leave one of these as a group activity for you. I will not tell how to do it because I hope that will cultivate or foster some amount of collaboration. Maybe I'll explain one, or maybe if we don't get time, I won't explain either, and I'll expect that we all collectively figure it out. Of course, I'll be there to support the findings. So if you let us start with first downloading it. Let me know if anybody has not yet downloaded this zip file and unzipped it. If you download and unzip it, you should notice that you will end up with a directory called ML400, which is the ID identifier for this workshop.
So Asif, I do not have access. I don't know if I told you last time.
Oh, yes, you do not have access. Are you registered to this site at all?
I could not register. It says that you're already there, and I can't get the
Let
username
me
and
take care of your account right now. I'll do it. So, guys, today it's all practical. We need to, oh, I needed to confirm. All right. And now you'll be able to access it.
okay.
That's all it took. Let me make sure that you are in this workshop page also. Anyone else is having difficulty accessing it? Acha. All right. So now you are there. Uh,
Okay. Thank you.
and I'll wait a minute for everyone to be able to download this file. Can I please get some confirmations? Anyone confirming that they have successfully downloaded and unzipped it?
Yes, Asif, they can. Yeah.
All have done that. Wonderful. So our next step would be, and this is something that many of you have already done if you're coming through my previous workshops, but we'll just sort of go through the motions again. What you do is you go to the website anaconda.org. It might be a good opportunity to upgrade because Python 3.8 is out, 3.85. If you're still on an older version of Python, 3.6, 3.7, it is worth upgrading. Some functionalities have really improved gradually, and we will actually be using the features of the latest Python. So you'll see that we write rather idiomatic Python, which means that,
Asif, do we need to down, uninstall our older Anaconda or?
you see, Anaconda is just a directory. I would say that just if you just copy it over elsewhere to something else, and then download Anaconda, the latest Anaconda again, and install it, run through the install process, you'll be fine. So you have a directory called Anaconda 3. It's like, if I remember right, you work on Mac, isn't it?
No, Windows.
You're on Windows. So you must be having a directory called Anaconda 3 Nisarg. Just rename it to something else. You can uninstall it if you wish, then you'll have a clean install. If you have a good internet connection, by all means, just go ahead and do that.
Asif, I think we'll try to do that next class, right? Again, I'm in the older version. I don't have the
Okay.
newer version. Is that okay for the first class?
I think you'll follow through. Occasionally, one or two places the code may fail. I'll tell you where it will fail if you're on an older version, but you don't have to do it. If you have Anaconda fairly recently, as in 2020, you installed it, you should be fine. For those of you
Will,
who have not,
will we lose our original packages which we installed if we reinstall it?
see, generally you can upgrade Anaconda, but in my opinion, upgrades are usually not very clean. Right? You can just do update of Anaconda, and that will take care of things. All your package will stay. My experience has always been that keep replacing it with new installations every once in a while because it's just a directory. You rename the directory to a backup directory and reinstall it.
Got it.
So, guys, here we go. If you go to the anaconda.com website and or org website, I would say .org, you will see a download link for the individual edition. You click on the download link, and it will ask you Windows, Mac, and Linux. Which of the three operating systems you prefer? As you notice, it says that it is Python 3.8. It's a very easy installer. For each of them, it's a graphical installer. For Linux, obviously, Linux, the culture is not to use graphic installers too much. It's just a simple script that you can run through. So just run through that script and you'll be done.
Is there a way, Asif, to check what Python version you have on the Anaconda that exists?
Yes, it's very easy. Just say Python, then space, hyphen, hyphen. This is the command you would give. Let me see. Now I'm doing it from a teaching laptop, which is Windows, which I don't use for any other purpose. But let's see if it has one. Yeah, do you notice that? Oh goodness, this is an ancient version of it. But I'm connecting from this to my Linux machine, which has, let's see what the Linux machine has. Let me see if I've enabled SSL access to it. No.
So Asif, there is 4 and 5 and team edition and individual edition.
No, go with the individual edition.
Okay. So I have a different page. I Googled it and got, okay.
Okay. So usually going through anaconda.org, and I suppose they're trying to also commercialize it. But if you
docs.anaconda.com. I got to docs.
Yeah, it will take you to anaconda.com. They click on the download button. It should take you here, and all you need to do is install it. Guys, I'm going a bit slow because I know in the audience there are a few people who do not know Python. So for that, I have a announcement. This Saturday in the afternoon, we will have a Python session. It will happen right after the quiz. The quiz will happen at noon, Saturday noon. And right after that quiz, the quiz should take about half an hour to review. And then from 12:30 onwards, there will be a Python session for those of you who are interested on Saturday. Once again, if you are interested, please do mention it in the social forum. At this moment, I have received only one person, I believe Premjit, who has said he would be attending. If you are interested in attending, is there anybody else who would like to attend that?
Asif, I could attend.
Yeah, sure. You're welcome. Anybody else?
Yes, me too. This is Gino.
Okay. All right, guys. So remember, 12:30 on Saturday. And 12 o'clock is the quiz. So come at noon. Every Saturday noon, we have a session. Come to that. And after that, we'll do this. After the quiz.
Sorry.
Go ahead, Nisag.
Do I change the name of the directory or do I change the old directory's name?
Usually, I rename the old directory and install a clean one.
Okay.
But Nisag, if you have installed it recently, then it's fine. I believe you were there in the summer class. No? So
I have 3.6.
Oh, that's ancient. Yeah, get to 3.8. So I'll send you guys a notification or an announcement of this. But Saturday noon, generally Saturday noon, we keep for help sessions. We review the quiz, we do the remediation session. And after that, if time permits, as time permits, those of you who need individual help with your labs, you can get that individual help from me. All right? Now, once you install Anaconda, then what you do at that particular moment is you go into the directory. Actually, I might as well do the same thing as you guys are doing. Let me do that. Because I don't have the setup on this laptop. I could just repeat it. Once you have done that, what you would do is you would go into your folder where you have installed. Yes. Suppose you have installed, maybe I should repeat it with you so we can all do it together. Let me get this code base also here.
Asif, your voice really goes down when you turn
It goes
around.
down, huh? Okay, let me fix that. 1 second. I'll change the speaker altogether. 1 second. Is that better now? Is it still fading?
No, this is better.
No, this is
Now it is better, right? Okay.
Now it's better.
It's better. All right. It's now I put a omnidirectional speaker or microphone, so it should catch my voice from everywhere. And I'll get this speaker out of the way. Get this microphone out of the way. All right. So guys, once you have unzipped this file, hang on, I'll go and unzip it wherever it is. So guys, okay, anyone needs help with that? Unzipping the file and entering the directory? No, right. So what you would do is you would bring up Anaconda. Do you see Jupyter Notebooks, Anaconda Navigator? Once you install, and this is just for beginners. Gradually, you'll be able to bring up Jupyter Notebook from the command line. It is just Jupyter space notebook. But in the beginning, when you're just getting used to it, one easy way that you can play around with this is you can bring up the so-called Anaconda Navigator, and here we are. Remind me later. So do you see that you have Jupyter Lab and Jupyter Notebook? At this moment, start with the notebook. Are we together? When you launch the notebook, you'll end up somewhere in your home directory, and you can navigate to whichever directory you installed you downloaded the starter pack, the homework one starter pack. Right? So you can go to that directory and look at that. Am I making sense, guys? And when you do that, you will end up with something like this. Once you enter that directory, which is your ML400 directory, you should see something similar to this. Let me know if you are seeing something similar to this.
So as if it forced me to go to the cloud, Anaconda cloud. It's not allowing me to download. Is that how it is, or?
No, it should allow you to download. If you share your screen, I can help you. I mean, it says the cloud, but if you click on the download button at the top, right, you see this download button at the top, and then it takes you to the individual edition. You click on the download, it takes you to your specific version, and then you download that. That's all.
Okay, so.
You're not able to do that?
No.
Okay, why don't you share your screen?
How does it work here?
In Zoom, look at the bottom and you'll see a place to share your screen.
Zoom. Through Zoom, correct?
Yeah. And if anyone else needs help, remember that Dennis, Shen, and Prachi are both here. We also have a few volunteers for helping with the labs. Those of you who are volunteering, could you please post a message on the social forum that you are available? Should I be looking at your screen now? Am I looking at that? Not yet, eh?
Not yet. You can choose to quit now or do it on your own. Why is it? Zoom will not be able to record contents. It's not, yeah. I think it's because you're recording. I think it's not allowing me.
Yes, I think that may be a limitation. So what are you doing? Let's try to understand what you're doing. Are you saying you're not able to click on this download link here? You see on my screen a download?
Yeah, it's forcing me on the, okay, so
if you have to stop sharing and then you can share it.
I should share that. Okay, maybe I should
stop sharing.
All right, why don't you share it now?
Anaconda 3.71, okay.
I suppose so, whatever is the latest. But see, if you're close to the latest is good enough. Huh?
Okay.
Oh, I thought, when I downloaded, it said 3.4 for Windows 4. I don't know.
You are on, I'm not sure I heard that. You are on Windows, the Anaconda 3.4?
Yeah, that's what it gave me when I downloaded the latest.
Oh, that's fine. It's probably the latest.
Correct,
Anaconda
yeah.
3.4 sounds like the latest. You're fine.
Because I heard somebody say 3.7.
No, 3.8 is for Python. Yes. All right. So you are here, isn't it? Please bring up your browser a little bit up. Don't click on get started. Yeah, just click on individual edition. Yes, let's try our luck with that way. Scroll down, click on the download. That's right. Let's click on that. And do you see the download happening here?
Yes. Should I didn't realize it. Okay,
Okay.
my bad.
Yeah, nice. Well, all is well that ends well.
Okay, let me give back the control so that you can continue recording.
Sure.
Thank you.
You're welcome. I believe the recording is still on.
Am I still sharing?
No, I'm sharing the screen now.
Okay, great.
So guys, how many of you are looking at a screen like this? Like you're able to bring up your Jupyter notebook, you're able to navigate to the directory. Anybody at all?
Asif, we've been posting the chat wall has been there.
No, I didn't hear that.
In the chat room, we've been posting who all
Oh,
are at that place.
okay. And does it look like most of you are?
Yeah, I'm able to access Asif.
Yes, Asif.
All of you are. So I can continue from here. So
Yeah.
guys, I'll give you a navigation of the way the projects will work. Every week, I'll give you some starter code. The code would be for our walkthrough. And then in every of the notebooks, you'll find some homework waiting for you. And those homeworks are very easy. They're simple practice and extensions of whatever it is we cover today. Now, today is sort of a basic lab. We are getting started and things like that. Gradually, this workshop will pick up speed. So do brace for it. Keep up with it. If you don't keep up with it, you may start falling behind. So, but today we'll go a bit slow. So once you are here, in Python, you have something called a requirements file. If you click on this requirements file, it will tell you what are all the libraries that we will need. Now, most of these libraries you can install using there's a pip install command. Maybe I should mention it right here itself. You have to give this command pip.
Asif, I'm still not there yet. How do we get? I'm done downloading the Anaconda.
Yeah.
After that, what is the step?
From your menu, bring up Anaconda Navigator. And then start Jupyter Notebook. Now, for those of you who are more familiar with this, of course, you can just give the Jupyter Notebook command. But at this moment, do go through this route. If you bring up Anaconda Navigator, you'll be looking at a screen like this. See if you can come to this.
So this is inside the downloaded
Anaconda. No? Did you install that Anaconda that you downloaded?
No, not yet. That's what I'm.
You have to install that.
So I have. It's a .sh. So I just have to run the script.
That's right. That's right. Rafik, you're working on a Mac or you're working on a
Ubuntu.
Oh, you are on Ubuntu. So then it will be very easy. Just run that sh file. By the way, of all the operating systems, AI is just easiest on Ubuntu. It is the next easiest are other flavors of Linux. Then comes Mac, and usually Windows support is a little bit flaky, guys. So you might be in for a lot of pain if you're running Windows. Some things will work, some things won't. Usually what doesn't work is the fact that your code doesn't use the graphic libraries, the GPUs. To get very good support from GPUs, make sure that you have a machine that has a NVIDIA card and is running Ubuntu. Then you won't have any issues. All right, guys, can we make progress? Can I move forward from here? Rafik, can I move ahead now?
Yes, you can.
Move ahead. So, so let's look at this. This is your requirements file, as I mentioned. Requirement file is its purpose is at some point give a command like this, pip install. I'll just do even more big. You can take it down, pip install -r requirements.txt. It's from the command line. Open a command line And once Python Anaconda has been installed, and you give this command, it will install everything in this file, right? These are the things we will need one way or the other for the first homework. Right. Now, one good news is while you're doing it locally, usually, and I'll show you how to create a Jupyter notebook in Google Cloud, there you can choose to create a compute instance which is fully configured. You don't have to do anything at all, right? And that's the nice thing about it. But for doing it on your laptop, and it is good to start on your laptop so you have some feel for it, you have to do everything manually. And we are going through the process of doing it manually. Premjit, how far along are you?
I'm good, Asif.
Nice.
I have an Anaconda environment on my Mac already.
Already, excellent. Excellent. So once we are here, now let me give you an understanding of the other things. When you, this particular thing, you can read it. A couple of things that I would suggest is, how do you author Markdown? Whenever you're authoring Markdown, people often say, I have to learn yet another language. You know, Markdown has its own syntax and I have to pick up the syntax. Markdown is a very simple language. It has become a de facto standard amongst programmers. It's sort of like a 5 minutes learning curve. However, there is an excellent and open source um, environment for it. It is this. And I'll just show what it looks like. Let me see if I have it in this machine. Yeah, Typora. Do you notice that on my machine now a window has popped up? It's an application called Typora. And then I can go and write anything I want. For example, I'll say we are at, and you can do all of those things that you, like for example, in the beginning, if you don't know, you can do it. And now you can write this, these, some. As you can see, it can do that. And you can create bullets and so on and so forth. And it gives you support for all of those things. You can introduce horizontal lines. So many, many things. In the beginning, if you don't remember the syntax for, it can say item 1, item 2. And then you can save it as a file and it will do that for you. It's a very good environment, in my view, for writing Markdown, besides just writing it in plain text. So that is what I was going to mention about it. It is Typora, Typora. And in this project, you will notice that I have a file here called authoring Markdown. These are all the very basics, right? One of the things, if you want to know how I use it like this. I use Typora. The theme that I use is Pixel. I turn on the focus mode. It helps you really concentrate on the part that you're writing. Turn on the outline so you see the bigger picture. And there is also a very good Markdown support in Sublime Text. Those of you who are using Sublime Text, it's also there in Atom editor. And I'm sure it's there in just about every other editor. Eclipse has a support for it and so forth. I'm sure Visual Studio Code would have a support for it, but I haven't checked. So that's something worth looking at. The next is the hardware considerations we covered last time. I wouldn't go into that now. Now, let me explain the directory structure here, guys. This text directory contains a few sample text files. These are sort of the famous classics, like for example, the United States Declaration of Independence, the Lincoln Gettysburg Address, then Shakespeare's sonnets, Charles Dickens' Tale of Two Cities, India, when it became free, the Tryst with Destiny speech. So if you can click on it, you will come across the text for that. We are going to use this text for today's lab at some point as we make progress with the NLP. We'll get introduced to a topic called natural language processing. Today, when we do natural language processing, we'll do very lightweight AI. It will just be getting introduced to the topic. But it's a good day to start. Other than that, there is a directory for handling data, but this is empty, ignore it. There are two important directories. One is notebooks. Notebooks is for Jupyter notebooks. And as we learn is our library. In other words, what I have done is I have taken some of the complexity out and put it in the library here. You can go and read this, not all of it, but read whatever you can. I'll tell you what is worth reading as part of the homework. And when you do that, let's say that you go into, let's go into what? A transfer. Right? And if you just click on that, you will come across source code. I would say that when you come across source code like this, in the beginning, it may look very intimidating. Read it, glance at it. After a little while, it will become familiar. I do not expect you to make much head and tail out of it yet. Right? At this moment, focus only on the notebooks. Right? But these are the codes that I have put there, this Python code, to make your life easier, to make it easy for you to navigate through this workshop. So we will focus on the notebooks first. Here are the notebooks. Now, when we run our notebook, one fact that will be there is that we need to include our SVLearn in the path before we run it. And so you'll see everywhere in the beginning, I'll be putting the SVLearn thing there. Now, if you're running in a Jupyter environment or a Colab environment where you may not always have access to the shell, then you can run this script. What this script will do is just a one-liner. The purpose of this script is to make sure that in your environment, all the necessary libraries are installed. All it does is it installs the requirements. So when you run it, what will happen is, and I'll show you what happens, you go into a notebook. So guys, this is saying navigating to a notebook, opening a notebook, many words for it. And a notebook is made up of two kinds of cells. You notice here, two fundamental things. These are the fundamental units. These units are called cells of a notebook. A notebook is essentially one page. It's a file that ends with the extension IPy notebook, IPYNB. Any file that ends with this extension is a Jupyter notebook. Now, Jupyter notebook is comprised of many cells. In this particular case, we have three cells. One cell of text. The text is always in Markdown language, which is why I emphasize learning Markdown. Do you notice that this is a hash mark means it's a heading? After that, it's just plain text. It will respect your line breaks as paragraph breaks, new paragraphs, and so forth. So this is text cell. This is code cell. And this is, of course, an empty cell. We can get rid of it. So two cells are there, code and this. Now, when you have a code cell, Jupyter Notebook allows you to do some sort of magic. Whenever you see this exclamation mark, think of it as one of the magic commands. It just, exclamation makes you escape and give a command in the underlying machine's shell. So if you're sitting on Ubuntu, you can give this command directly from the command line. But if you want to give the same command from inside a Jupyter notebook, what you do is you prefix it with an exclamation mark, and then you run this command. Let us see what happens. So what happens when we run this? It becomes nice looking text here. And what happens when we run this cell? Look at this. This cell ran. And what it is saying that on this machine, by the way, this machine is not the laptop. I'm connecting it to this machine called Meta, which is my Ubuntu server. And there, all of these things are installed, which is of course true because I work on that machine. Things are installed there. Right? So I invite you to run this command in your notebook. If you have successfully opened it in Jupyter, please go and run this notebook. Now you can run this notebook in many ways, guys, and this is becoming familiar with Jupyter Notebook. You will see that there's a kernel here. Kernel is the back-end engine that runs your notebook. It's sort of like a client-server model. Your Jupyter Notebook is ultimately just a HTML client. It's a thin client. But it communicates with the backend, in the backend, with a server, Jupyter server. And each notebook is considered a kernel. At the backend, the thing that manages this notebook is the kernel. So you can do all sorts of things. You can restart, clear output. So for example, if I restart and clear output, let's see what happens. You saw that output disappear. You can say run all, right? You can just say restart and run all, and so on and so forth. So you can do all sorts of things, reconnect to the notebook if your connection gets disconnected. This is particularly true if your kernel is elsewhere. Like for example, in my case, my machine is on Windows. I'm doing this thing on Windows, but the server is obviously on a Unix machine, an Ubuntu machine. So you can do that. So anyone of you could confirm that they successfully ran this file?
I did.
Wonderful. It worked, right? I hope there were no surprises there.
Yeah, me too.
Yeah, it
It
worked.
worked.
Excellent. Excellent.
It
So now
looks like
come,
it was already installed. So.
yes, wonderful. So guys, now I'll start with something, with the main thing. See, Jupyter Notebook is sort of like an IDE. It's a development environment. If you go and read my notes, which I hope you did about the hardware and the installation, I suggest that you install the Jupyter extensions also. When you install the Jupyter extensions on your machine, a lot of facilities, a lot of features become available, which normally are not available, like the ability to generate table of contents. Do you see this here? You can generate, you can see the table of contents. So when your notebook becomes very long, it's very hard to keep scrolling up and down. You can just quickly go to the table of contents and see it. You also get a lot of extras when you install that snippets. So you have snippets, you have examples where I have not fully installed it here on this machine. You can do highlight text, you can do all sorts of things. You can prettify your code, you can make sure that it looks nice. And there are many, many things you get along with just getting this. You also get the ability to introduce LaTeX, right? So suppose I'm here. Let's try this as an example to illustrate what I mean. Suppose you want to write a mathematical expression, and let us say that you don't know how to do that. Right? A lot of people don't know. So you can say, well, how would I, for example, write an equation? Here we go. Do you notice that it wrote the LaTeX syntax for equation, right? Equation, let us say this is equation quadratic. I'll give it a name, quadratic equation, and we can say y is equal to, what is it? 3x square plus 2x plus 1. Let us say. Let's see what happens. Do you notice that you got beautifully mathematically formatted equation here? So these are facilities you get through that. Likewise, you can have these widgets. You can embed some widgets into the code, into this thing. And there are many ways of doing widgets into this. I won't mention it, but I'll talk about widgets. What are widgets? There's a separate notebook that illustrates that point. So this is becoming familiar with your Jupyter notebook. It's something that takes some time, guys, huh? But nothing is hard. And the way to do that is to start with the very basics. And every once in a while, you'll notice something useful. Somewhere, you'll come across something that you'll start finding useful. Like for example, for this, suppose you want to write some Python code. You'll notice that there are a lot of examples already here. Right? So for example, how do you go and do a list comprehension, which is something very Python specific. So people who come from C, C++, Java background, they have no idea what a list comprehension is. So it is this, and we'll talk about it in the Python class. It just says that from -10 to 10, right, for all the numbers, so that would be 21 numbers, you produce the square of them. Let's see what happens. Sure enough, you see the square of those numbers. Right? And this is again Python specific syntax. When you're learning Python, you may not remember a lot of these things, but you can quickly look up the snippets and use it to do. Likewise, you can use this markdown to insert, things like that, insert local video, insert remote video, and so forth. So for example, here, right here, suppose you want to do, and again, I'm just randomly moving around. Let's say that you want to insert a remote image. All you have to do is, well, this is a bad place. after the equation, let's say. Here we go. Then obviously this image doesn't quite exist, but if you go and bring a real image, let us go and get a real image for that. And there are many sites for free images. We will use images a lot in this workshop for our deep learning. So get familiar with this. Unsplash is a great site to get images. So let's say zebra. This looks like a perfectly good zebra. Let's copy the image address. And once we have copied the image address, let's add it to, where were we? We don't need this, we don't need this, we don't need this, we don't need this. We were somewhere here, instantiating. Yes, we were here. So we can go here and we can put this URL. Once again, if you're familiar with HTML syntax and markdown, etc., so sometimes you may say, well, I don't need to be spoon-fed. I can do these things on my own. But when you are entering this field, a lot of people who come into this field, they come from a deep, back-end database background, database housing, or they come from systems programming or for embedded systems and so on and so forth. So they may not be familiar with markdown and HTML so much. So you notice that with one click of a snippet, we are able to bring a zebra into our story. Right? So these are the snippets aspect of it. You can introduce LaTeX, you can introduce even this. As you write code, for example, you want to plot something and you forget how to do a plot. You can go to the basic plots. For example, you feel like making a 3D plot and you have forgotten the syntax for it. Let's go and do that. Here we go. Now, if you look at this data, it's a very simple data. It just takes X and Y values and it creates a, by now, if you look at this, you would realize that it is creating something like a, well, you'll see what it creates. It's very simple. And it is creating sine X square plus Y square. It looks up a particular shape with ups and downs. This. And you can run this. Yeah. Oops, NP. I forgot to import NP. Import. Let's try a lot now. Plot. It needs matplotlib plot. As you can see, not all this plot. Sorry, import as PLT. Hopefully this should solve our life now. There we go. So do you notice that, guys? You got it. But the thing is that by having this snippet, you can quickly see or get an example, and then you can iterate over it. Maybe your data range is different, your function is different, but here is a way to quickly see it. Use these snippets. Today, I've given you a homework, which will require you to use the, actually, is it today or next time? It will require you to do 3D data visualization. So that is about notebooks. Now, in notebooks, there is one feature that is quite useful. If you want to make the notebooks interactive, in which you take values from the user, you can actually do that. Excuse me for 1 second. All right, guys, so here we go. What can this do? This helps you, you can install this and it will, in my case, of course, everything is pre-installed, but I wanted to show you what it does. You import it and suppose you want to have a function, F function X, and you want to create a slider. Do you notice that you have a slider now? You can use the slider to capture the value X, what the user enters. Likewise, in your notebook, you can have Boolean, you know, true, false. You can have a text. The user can enter a text. You can play, and these are just examples. You can play from here. Do you notice this? It's a play button. You can play from certain value. And this is very good when you want to run a few epochs, or you can start with certain values during your deep learning sessions. These things I'm introducing you to, obviously you may wonder why, but become familiar with it. You'll need it in due course of time. Likewise, you have a date picker. You can pick dates. These are standard UI components. People who know UI in every language, they look forward to these components in HTML, in JavaScript slash, jQuery slash, I don't know, Angular, etc. Then in Qt and whatnot. This is something actually you might like, and most of you, especially those of you who have been doing ML100, 200, you know that we paid some attention to formatting our data frames, data tables. This is something different. It gives you interactivity in your data frame. So let me show you why it is. And it is something that I like very much, actually. This is called a QGrid. Surprisingly, most people are not aware of it. So once you do this, let's see what happens. Here is some data, some random data. This is the iris data set. What am I doing? Can one of you tell? And obviously, those of you guys who are new to Python at this moment, I apologize, but I'll explain what it does. This line loads a data set called iris. Iris is sort of like the hello world of data science. One biologist, one fine day, walked into a meadow where iris flowers were growing, and he picked up, I believe, 3 species of iris, and he picked 50 samples of each. And he brought those 50 samples, so total 150 samples of iris flowers, and he measured carefully the length, the width, the petal length, petal width, sepal length, and sepal width of each of those iris flowers, and tabulated them by the species they belong to. So that data set is the iris data set. It has 5 columns: petal length, petal width, sepal length, sepal width, and then of course the species of the iris. And those of you who are familiar with iris would know iris is one of the most beautiful flowers, and it comes in a tremendous variety of shapes and sizes. Different species of iris look quite different from each other. They all look beautiful, but they all can look quite different from each other. So this data set is interesting because in machine learning, we try to build models to see if the machine can learn how to distinguish between one species uh, and another. Quite often you'll see very scholarly research papers, and they would explain the algorithm and they'll show how well it works on the iris data set. So this is the iris data set. We load it into something called a data frame. A data frame is nothing but like a spreadsheet representation of your data. And then you take the data and then you give us basic statistical summary of it. Describe will give you descriptive statistics. If you remember the descriptive statistics from your school days, it's your mean, median, standard deviation, and the quantiles, min, max, and 25th, 50th quantile, and so forth. These are the headings. And here is the table. If you look at the data set itself, just do data frame. This again is very familiar. It has, again, as I said, 150 rows and 3 species. Target value has value 0, 1, 2. But now see what happens if I try to run it through this. Oh, why did my grid not show up? It should have showed up. Okay, something is off. I'll fix this code. It should have showed up, maybe because of the remote or something. But what will show up here is a beautiful, the same data frame here, but with the ability to play around with it, filter it and do things the way you see in rich HTML or jQuery or Angular-based components. And I suspect it is backed by something like that. It comes out very interactive. So these are the interactive elements of that you can embed in your Jupyter notebooks. I'm emphasizing Jupyter notebooks quite a bit. And by the way, these are taken from a particular article here. You can go here. Maybe we can see it working there. 1 second. Jupyter widgets, date picker, color picker tabs. Yes. Do you notice that you can do pretty fancy stuff, interactive stuff with your pandas data frame the moment you wrap it up with this widget? Are you guys able to see this visualization here? I'm not getting any response.
Yeah.
You are.
Mm.
But
So, Asif, what is this article? Can you put that link in the chat?
oh, yes, it is very much there in your code itself, right here at the very top. Read this article.
Thank you.
In the notebook itself. So whenever I take, usually you'll see that the notebooks come with a lot of references to articles to read. So do read that and you'll have fun with that. Okay. So that is about widgets. Now let's get more real. We will use a framework in deep neural networks called PyTorch. There are at this moment many competing frameworks. There's Theano, Caffe, TensorFlow, and then there is PyTorch. Of all of these, at this moment, the mind share is taken by TensorFlow and PyTorch. The way it started out, first there was TensorFlow 1. It was very low level. It was, you had to describe a whole graph and how the execution graph would be pushed onto the GPU, the graphic unit, the graphic compute engine. And a lot of people found it very hard to deal with and debug. It didn't look like normal code. It looked like very clumsy. So people in the open source world, they created a project called Keras. Keras really put a layer of simplicity and rationality on top of TensorFlow and became a runaway success. Everybody wanted to use Keras. And Keras was also a layer, I believe, on Kafka and other things, but primarily on TensorFlow. Then Google ended up taking their main Keras developers and making Keras the front end to their TensorFlow. So the TensorFlow 2.0 has Keras as its front end. Also, because TensorFlow 1.0 was getting problematic, then Facebook came out with PyTorch. The PyTorch is a very, very intuitive data science or a deep learning library. People who are familiar with NumPy library to deal with arrays and matrices, they just, there is no learning curve at all. If you have worked with NumPy and scikit-learn, and those of you who have been with me doing ML100, 200, you all have. You realize all of a sudden that there is very little new to learn. You already hit the ground running. There is something to learn, but from day one, you can become productive. So that is PyTorch. PyTorch has been gaining a lot of momentum. At this moment, the way it stands is that the community used to be predominantly TensorFlow, but now more and more it became PyTorch. PyTorch has essentially taken over. At this moment, it is at 50-50, but the momentum is with PyTorch in the research community, partly because when you write code in PyTorch, you'll realize that it's very intuitive. With the TensorFlow, the world is like this. If you can write that code in Keras, it will be even simpler than PyTorch. It's very easy. But the moment you want to do anything beyond just the copy paste or the basic, the cookie cutter stuff, then Keras doesn't take you very far. You have to go down to the underlying TensorFlow libraries, layers, and those layers are frankly a pain in the neck. So I used to be obviously predominantly TensorFlow, but in recent years, like everyone else who likes to write their own neural architectures or play with things, I have moved to PyTorch. As we go through this workshop, actually the previous incarnation of this workshop, or the precursor to this workshop was in TensorFlow. This one will be in PyTorch. So I would like to introduce you to PyTorch as a library. And I hope you'll agree with me that if you know the standard numerical library, NumPy, it will be very easy. Now, those of you who don't despair. Remember, we have the starter sessions on Saturday. You'll become experts at it in 2 weeks, like 2 sessions, 2 Saturdays, and you'll be very smooth with it. It is easier than it looks. But going forward, let me show you what I mean by that. Now, most of you are familiar, except for the import torch, I hope this import is almost like a necessary song you all sing in the beginning of each of your notebooks, Jupyter notebooks, isn't it? These lines that I've highlighted, I trust you guys are all very, very familiar with. Would anybody like to agree with that?
Yeah.
NumPy, Matplotlib. So what does it do? This is the numerical library NumPy. Matplotlib is the plotting library, and really well done. I would see one of the things that you realize in data science, the data visualization libraries are just absolutely wonderful. Absolutely wonderful. You can do a lot of visualizations with just a couple of lines of code. And it isn't that the libraries are there. You have a problem choosing between many excellent libraries, many excellent libraries. It's sort of, there is not enough time to learn all these wonderful visualization libraries. People have really gone out and put a lot of effort in the world of R. Of course, ggplot is very respectable, is based on the grammar of graphics. ggplot and D3JS in the world of JavaScript are both influenced by a philosophy called the grammar of graphics, very influential philosophy. That philosophy has also influenced Python world in the Vega and the Vega Lite framework, based on which we'll use Altair. But the old visualization framework in Python is Matplotlib. It is the simplest, it's the one most often used till people become more conversant with powerful libraries. So take this as a baseline, just as in our language, if you just give the plot command, it comes built into R. The plots don't look very pretty, they don't look amazing, but they get the job done. Right? In the same way, Matplotlib comes under that category. Now, Matplotlib has been putting in a lot of effort these days to be compatible with the richer libraries. So one of the things that people haven't yet realized, that actually you can write Matplotlib code, but you can tie in one of these richer libraries like Bouquet and so forth, or Seaborn, and your your same code will get rendered more powerfully using this more powerful visualization backends. It's just a fact I'm dropping now. We will see illustrations of it as we make progress in this course. So let's try to understand this course, what it is. This is a magic. So you see this percentage something. This is a magic command. It basically says that when I plot something, I shouldn't have to say a plot.show. Just assume that any plotting, the moment a plot comes into existence, you render it inline in the page itself, right? And not in a window, not somewhere else. Literally in the Jupyter notebook itself, you render it. So that explains these three lines. The one new line that you encounter is the very first line, import torch. That imports the PyTorch library. Are we together?
Asif, one quick question.
Mm-hmm.
Somehow the import torch is just giving an error for me. Maybe I missed something in running? Somehow the requirements.txt also didn't run through fully for me.
That is the reason. That's the reason, Ramki, why you're getting that. So what we will do, that needs to succeed, right? Because that will install the libraries. And so come to the Saturday session. We'll sit on one-on-one and fix your environment.
Okay, perfect. Thank you.
Yes, excellent. So, all right, guys. So I'll just give a few illustrations. Here is a standard NumPy code. If you look at this code, I hope you all will agree that looks very easy. You create a linear space of numbers from -2 pi to pi, and you create how many of those numbers? You create 100 of those numbers. This is the beginning, this is the end, and how many numbers you want. So it will create an array of 100 numbers going from -2 pi to pi. Then I'm writing y as a function of x. I deliberately wanted to take some complex function. This function is a sine wave in x, but with an exponential decay built in. You notice I put an exponential decay here. Right? So if I have to write, so let us write the mathematical formula for that. It is begin, sorry, equation and end equation. So now, can somebody tell me how I would write this? I would just copy this and remove the NP here. This is language now. Let's try that now. And all you're doing is, you notice that people who write mathematics are used to writing in this funny syntax. And let's see. Oh, no, I made a mistake. Solute. Right. This is it. Or if you want to make it look more traditional, you can say like this. There we go. Do you see this equation, guys? What I've done is I've taken a simple sine wave and I put in a decay so that it decays down. Why did I do it? No particular rhyme or reason. I can change this equation. You can make it whatever. I just wanted to take some equation of x. So I took this. Now let's run this. If I plot this, right? Oh, NP is not defined. Let's run this. So this equation comes. And now let us get introduced to PyTorch. We will compare this. I will just decrease the fonts a little bit. Look at this, guys. This equation, this is the standard code for writing it in NumPy that you're familiar with, and see how we write it in PyTorch. Can you tell what the difference is? All we did is we replaced the NumPy NP with Torch. Can you see that, guys? And amongst the more marvelous things is the fact that matplotlib works just fine with Torch objects. So Torch objects are called tensors. Tensors is a mathematical term. They are a generalization of matrix to higher dimensions. We'll talk about tensors, the concept of tensors we'll cover next time. But just think of like a array is one dimensional, a matrix is two dimensional. Now, how would you generalize a matrix to 3 dimensions? Add a z-axis to it for numbers. When you were to do that, it becomes a tensor. And tensors are of arbitrarily high dimensions. They can be a point, a number is a tensor, and all the way to any number of dimensions you can have. So it's a generalization. Right? Now, in NumPy also, you could do that sort of thing. So one question that comes is, when NumPy exists, why would you create a library that pretty much mimics its API? Would somebody like to take a stab? Why in the world would you create a library like this?
Extra features.
And what are those extra features? What are the big things that NumPy doesn't have?
Some GPU.
GPU acceleration.
GPU acceleration is an important feature, but then, we could have put in effort to retrofit NumPy with GPU acceleration. By the way, the effort is happening. There is an effort to make that happen.
It doesn't support tensor.
You sort of, we can retrofit NumPy somehow to do that. See that you could extend it, right? Why create one more open source library? Actually, the reason is very interesting. It has to do with the fact that we want to express, or we want one thing in deep neural networks, or two things, just two things we need to do deep neural networks. And it's a relief, actually, when you think about it, that all these complicated textbooks and research papers, they can all be boiled down to two essential operations. One is matrix addition and multiplication, which is very easy. You know how to multiply an array with another array, right? In one way or the other, we can all do that. So matrix multiplication. And the other is differentiation of matrices, differentiation of functions. So what happens is when you describe y in terms of x, it would be nice if automatically the framework not only understood the moment you told y as a function of x, it also explained to you immediately and said, all right, now I know what dy dx also is. Wouldn't that be wonderful? So you don't have to explicitly compute it. So that is called autograd. The generalization of differentiation is gradient. So people call these libraries having the ability of automatic gradient, or put it differently or simply, automatic differentiation. That is a huge plus with Torch, PyTorch. Right? And when I use the word torch, it should mean PyTorch. Um, the other aspect, of course, is Torch is optimized to run on GPUs. It will run on CPU if you don't have a good GPU. It will run just fine on your CPU. It will just take probably 10 times as long, right? Or maybe 100 times as long sometimes. But it does run. So when you do the same computation with NumPy, what happens is the computation doesn't benefit from the from the GPUs, because NumPy only runs in the CPU. The CPUs are general purpose engines. They are not really optimized for large matrix multiplications. And by large, I really mean large. I believe in the session before on Tuesday, I mentioned that some of the latest transformers and these neural network models and CNNs like Inception, we are talking about parameter space that is in hundreds of millions or even a billion. Ridiculously large matrices we are multiplying. So to be able to multiply those giant matrices, you need dedicated video cards with uh, humongous amounts of memory. So some of you, I don't know if you have kept track with it, NVIDIA has just announced the RTX 3090. Right? I'm, for example, waiting for it to hit the market. The 3090 has, I believe, 24 GB of video sitting next to the GPU, the graphic processing unit, very close to the GPU, so that it has a direct path to the GPU. It doesn't have to go to the computer's memory. By the time you go to the computer's memory, it's already too late and too slow. So that's the benefit of using TensorFlow. That's what, I mean, either TensorFlow or PyTorch. These are libraries that are created with GPU in mind. PyTorch's ability to do automatic differentiation or automatic gradients is huge. Much of neural networks that we are going to learn, they have two steps. The forward step is just matrix multiplication, and so-called backward step, which is a propagation or a differentiation, a wave of derivatives or gradients propagating uh, back towards the input zone, right? From input to output. If you think of it as a long pipeline, in the forward direction of the pipeline, you have multiplications going forward. In the backward directions, you have the gradients flowing back. And we will see that. So anyway, suffice it to say that there's a good reason to have a separate library that looks very close to NumPy. Why is it deliberately made to look like NumPy? Because everybody in this world is more or less familiar with NumPy. By the way, even if you come with R background, you would say, well, bad luck for me. I come from R, I don't know NumPy. But actually you do, because below both R's library and NumPy is underlying it is almost always the same Fortran library, Fortran and C libraries. Those libraries are BLAS, Basic Linear Algebra System, and so forth. So those libraries have not changed, and nobody is foolish enough to write everything from scratch. They just put layers on top of it. NumPy is a layer on top of it. And so if you are familiar with R, it becomes a no-brainer to quickly become familiar with NumPy and therefore familiar with Torch. It's just that there's syntactic difference, language differences. Once you get used to the language difference, it becomes easy. Right? All right, guys, we're coming upon a break in 5 minutes. So I would like to finish this part. Likewise, a bell curve. You may say, well, you know what, that was perhaps too easy an example. It isn't easy. I wouldn't exactly call this function easy, but let's try something else. What about you take a bell curve? Bell curves are everywhere in machine learning. Here is the code for a bell curve. Right? There's a denominator. Maybe I should write the equation for the bell curve also. Might as well. Those of you who I should have done that perhaps. Would anybody like to remind me the equation of a bell curve? Equation. Y
e to the power of x squared by 2.
Fact this over this over 1, yeah, okay, 2 pi, 2 pi, 2 pi, and SQRT and SQRT square root. And then this would be, of course, the exponentiation of it, e to the power. Let me just use exp, exponentiation of what? Minus. Well, obviously, I'm giving the simplest version of a bell curve here, minus frac inside it, x power 2 over 2. Let's try a luck and see what happens. Oh, this would quite, it is correct, but it looks sort of ugly. So I will make it 1. Let's look at this. All right, guys, here I've taken sigma is equal to 0. The mean is 0. I mean, the standard deviation is 1. And what is the mean here? Mu, 0. Right? Centered at 0 and 1 standard deviation wide, a standardized bell curve. So, in this equation, I forgot to take the square root, but all right. NP, you can say NP SQRT further.
Standard deviation 1 no mean 0 now.
Mean 0 and standard deviation 1. Yeah, that is right. So guys, in this, I've forgotten to take the square root. I'll leave it there because we're coming up on the break, and I'll leave this as an exercise for you to fix in the break. So this is the NumPy code. And what is the PyTorch code? Do you notice the PyTorch code? Does it look exactly the same, guys?
Yeah.
That is it, right? So these things work very similarly, right? But then not always, it's not always true. So for example, the function syncx, it's a famous function that you use in signal processing, sin x over x. So if you write the NumPy version of it, you will realize that there is no equivalent of it in TensorFlow, but then that's no harm. All you have to do is take a tensor, convert it back to NumPy. So how do you convert a tensor back to NumPy? You just call the .numpy method to it, right? And it will make it into a NumPy, and then you compute the value, and then you convert it back to a tensor. So if you look at this line and try to sort of unpack it, what we did, we created a XX tensor. In this inner part, let's look at the inner part of it, this one. We have converted it to NumPy. Then what did we do? We used the NumPy library to find the sync of it, sin x over x of it, and then we have a NumPy. And then all we need to do is convert that NumPy array back to a tensor. And then we call the tensor method on it, function on it, constructor, and it will create a tensor back. So we have a XX tensor and YY tensor. Once again, you can feed it directly into your matplotlib, and it will do that. So here we go. This brings us to our first lab. This is your turn. Just imagine, create a function of your own that you like, and plot it out, and write the NumPy and PyTorch code for it. Pick your favorite function. You can take it in 1 variable, 2 variable, whatever you like, right? And create this. And guys, this is your first lab to do that. And so with that, I'll take a 15-minute break. Well, let's regroup. It's 8:30 in my clock. Let us regroup at 8:45. In the meanwhile, sort of review it and see, guys, if you can run this code, can you create any function of your own? Or try to take something complex and see if you can write the NumPy and the PyTorch equivalent of it. So you will realize that learning PyTorch is a no-brainer. It's very easy. If you know the rest of basic NumPy, you know it. And NumPy itself is just a set of very simple functions, NP dot, all your mathematics, high school algebra functions, trigonometry and algebra functions on numbers. As simple as that. Any questions, guys, before I'll open 1 minute for questions before we take a break? Anybody would like to ask a question? All right, guys, in that case, I will stop the recording and I'll stop the live stream.